Hello, my name is Catherine.
And my name's Julia. We work at Roche. Roche is a company that makes medicines for people all over the world. And today we're going to look at the techniques we use to make some of these medicines.
Let's see if you can solve the clues to figure out the name of our session today. I have a hint for you, but let's see if you can solve it first. Not sure? Let's take a hint. We have some equipment here. We have a funnel, a magnet, and a sieve. It's separation.
Now at Roche, we use lots of separating methods when we're making medicines in the laboratory. They're really important, and today we're going to make you masters of separation science. So, what is separation science? Well, this is when we use a specific method to separate a mixture of two different types of materials. The method of separation that we choose will depend on the mixture we're separating.
For example, let's look at this method for separating a mixture. What could the mixture be? Salt and water, or sand and water? The answer is B, sand and water. This method is called filtration. It can separate a solid from a liquid. The solid sand gets trapped in the filter paper sitting in the funnel. The liquid runs through the paper. And there you have it. You've successfully separated a mixture of sand and water. Can you see why this method doesn't work to separate salt water? When salt is added to water, the salt dissolves, so the salt is no longer a solid. If you pass the salt water through a funnel, it will all run through. So salt water cannot be separated using this method. Sand and water can be separated because the sand doesn't dissolve in the water.
So, why do we want to separate these mixtures at all? If you think about it, separating mixtures happens all around us in our day-to-day lives. Now, let's look at some pictures and consider what's being separated in each case.
We use water filters to separate impurities from our water, giving us cleaner drinking water. Coffee granules need removing from our coffee water mixture to give you a smooth drink. In some countries, they get their drinking water by separating salt from seawater. This makes fresh water that is safe for drinking. So quite often, something is useful by itself, but not as a mixture.
So at Roche, separating techniques are used all the time to ensure the medicines are safe from impurities and so that they work as best as they possibly can. Now, before we look at these separating techniques, we need to get familiar with a few words you may not be familiar with. Take a moment to look at these key terms used in separating science. Don't worry if there are some you don't recognise. Jot down 3 terms you're unsure of. They might be words you've never heard before or words you need some help with. So pause the video now for some time to write down 3 words you're not familiar with. Some of you might have guessed what we're going to do next. It's dictionary time. Get a dictionary or look up the meaning of your 3 key terms online. to make sure you really understand them, and try to use each one in a sentence. Off you go. You can resume the video once you're ready.
Let's see what you know. I'll call out a definition and give you some time to think about what key term that matches with. Let's see how many you can get right. Ready? Number 1. This is when a liquid turns into a gas. That's right. It's boiling. Let's have a look at number 2. This is when two liquids don't mix. We say they are. That's right, immiscible. Number 3. When two liquids do mix, we say they are miscible. That's correct. 2 more to go. Number 4. Gently pouring away one liquid. That's right, that's decanting. Now the last one. A substance that doesn't dissolve. We say that's right, we say that's insoluble.
Now it's time to think about the equipment we use for separation. Can you match up the equipment to the correct label? Why not pause the video and take some time to think? How did you do? You can check your answers here. Beaker, filter paper, tweezers, magnet, funnel, sieve, and pipette. How did you do? Did you get them all right?
Now it's time to bring all our newly acquired knowledge together. There are 3 main ways we can separate mixtures. The first one is called filtration. This works for a mixture of a liquid and an insoluble solid. Remember, insoluble means the solid will not dissolve in the liquid. For example, we can have mixtures of pebbles and water, or cornflakes and milk. If we add cornflakes and milk to the funnel, only the liquid milk will pass through the tiny holes in the filter paper, and the solid cornflakes form a soggy residue on the top of the filter paper.
Our next one you might be familiar with. It's sieving. Sieving enables you to separate different sized particles. For example, gravel from sand. Only the sand is small enough to pass through the tiny holes in the sieve, so the gravel gets left behind. It's similar to filtration, but sieving will also work with 2 solids, whereas filtration is used to separate a liquid from a solid.
On to our last one, decanting. This is when we separate 2 immiscible liquids. Remember, immiscible is when the 2 liquids don't mix together, like oil and water. The heavier, denser liquid will sink to the bottom, and the lighter one will find its way up to the top. By pouring slowly, you can separate one from another. In the lab, we do this more precisely. We use a piece of equipment called a separating funnel rather than pouring. It works in a similar way, but it enables you to get every last drop of water away from the oil.
Now, time for your task. Imagine you're given the following mixtures. Which technique would you use in order to separate each mixture? The mixtures are paper clips and rice, glitter and water, rice and water, flour and rice, and finally sand and salt. So, which technique would you use in order to separate each mixture? What would you expect to see? And can you explain why the separation method you choose works? To complete this task, you'll need to use the Separating Mixtures experiment worksheet provided. Watch out for mixture number 4. It's a tricky one. You can pause the video here to complete this challenge by filling in your experiment worksheet.
Now you should all be on your way to mastering separation science. What have you learned today? I have a final quiz to check your learning. There are 8 questions. All you need to do is select the correct separation technique. Are you ready? You'll have 10 seconds to think about your answer before the correct answer appears on the screen. Draining vegetables. What technique do we need? It's sieving. You can actually use filtering too. How about separating sand and gravel? You got it, it's sieving. How could we separate oil and water? That's right, it's decanting. Let's try a harder one. The diagram shows soil being separated from water. Do you know what B is called? That's right, it's the filtrate. Whatever passes through the filter paper can be referred to as the filtrate. Which of the following is a mixture? Remember, a mixture contains 2 or more different substances. That's correct. It's salt water. It contains 2 things, salt and water. All of the others only contain 1 type of material. Now, let's try this. Air is a mixture of what? That's right, gases. Adding salt to water in cooking involves which process? That's correct, dissolving. Remember, salt is soluble in water. And finally, warming an icy windscreen on a cold day. Think about what happens to the ice. That's right, it's melting.
All of the techniques you've looked at today are used at Roche. You'll see there's some more here. Distillation and magnetic separation. You've now got the separation science knowledge to research these techniques if you want to. So that's it from us.
Catherine
and Julia. We need budding scientists like you to carry on the work that we're doing.
Hopefully, separation science has given you an idea of some of the things that happen in the lab.